Let me introduce the third generation of SAKI 3D AOI. The current 3D machine is on the market since 2012. This is the brand new system which brings a lot of benefits for the new users. The brand new gantry can accommodate 3 versions, starting from dual lane, single lane for L size and the XXL size version. The gantry is driven by the ball screw, despite of the fact that the previous generation was driven by linear motors. And the programmable projectors were optimized in a way that we changed the projection angle in order to eliminate the secondary reflections, and the homogeneity was improved. Therefore, the height reconstruction is much more reliable compared to the current generation. One of the very big changes is also a 2D lighting system. We included the coaxial top lighting for shadow-free image, which is helping in the difficult areas with a high density of mounting. And also the lighting ring for side and low light was improved in order to get a seamless image without any shadowing. We have succeeded to speed up the machine by 20% compared to current generation. Let me show you how is the scanning process coming. So the reconstruction is done in a parallel with the scanning. It means when we scan the first field of view, the previous field of view is already reconstructed. This reconstruction is running on a graphical processing unit which is built in the PC. After reconstruction, the algorithm of the warpage compensation takes the place, and it flattens the PCB in order to eliminate all of the warpage which happens in the reflow oven or during the other soldering process. The using of the machine is very simple. Let me show you how we can program the machine. As an example, we'll select a fine pitch QFP, and we will design the shape and recipe library. The shape library is a geometry of the package, and the recipe library deploys the inspection step in there. All right, so first we have to define the shape library. The shape library can be selected from the golden library, which is supplied with the system. So the shape library includes more than 900 packages which are pre-programmed for you. You can select it manually, or you can use assistants. So I just need to select the type of the package, and the system will find the best fit of the shape library to my component. So as you see, the system suggested me 6 variants of this component. In a case that I don't have this information in my golden library, it's some kind of odd-shaped component, I can use a shape wizard, which helps me and guiding through the development of the geometry of the package. So let me start a shape wizard. As you can see, the shape wizard starts to analyze the image and the height information and suggest me what is the body size. As you can see, this is correct for this component, and I just follow the next step. After we fix the body size, there is a identification of what's going on around the component. You see that the system identified that there are lead arrays on 4 sides of this component. Therefore, the system suggests it is a QFP component. Let's agree on that, and then the system starts to identify how many leads do I have on every side, and what is the pitch of the leads on the component. The only thing what I have to set is the edge of the lead or edge of the tip. That's it. We prepared a geometry for QFP48, which was suggested by the system. So we can continue in deploying the recipe. In the recipe, I prepare a new recipe. The geometry is already deployed from the shape, which I showed you a couple of minutes ago. And I can use a tool called Recipe Wizard. In a Recipe Wizard, there is a list of the templates which I can use for automated generation of the recipe. It means of the inspection steps. In this case, I will generate a body, leads, and bridge elements. And for every of those elements, I deploy the 3 steps for body as checking the position, presence, absent, including the coplanarity and a polarity. For lead, I'll check the soldering, and for bridging, I'll check the bridge. Now we are in the menu of we started to program the first inspection step. As you can see, I see the whole map. The height map is displayed, and by the black color, you can see the PCB surface. Once the brightness gets higher, we see the higher object. So, in my task is to find out the height where the body is visualized without any interference of the other objects, like it is. For the coplanarity, I use an algorithm called find plane, which shows me the area and measures the distance between the PCB level and the component surface. Not only the height, but also the inclination. It means the angle between the PCB and the component. For the polarity, I can decide whether I will use a 3D approach or 2D approach. On a 3D approach, we can use on this component a pressed polarity mark. You can see the darker circle, which means that there is a little bit lower or deeper object on the polarity mark. So only what I need to do is to check the position. As you can see, I generated all 3 steps for my body. So now we will continue with the leads. For the leads, I define the expected position of the lead and the maximum and minimum height of the lead which I expect. And finally, bridging. The bridging I can do in 3D or in 2D. If I select 2D approach, I can detect very tiny bridges as like a hairy bridge, which gives us a lot of advantages. So we finalized all of the steps to prepare the library for QFP 48, and we covered the position, we covered the average height and inclination of the package, and the polarity. At the same time, we have the inspection of the leads, including the height measurement. And this algorithm tries to classify the joint and the lead in one of those categories. Finally, the bridging inspection.